You know that feeling when you type something into a search bar, maybe even misspell a word, and bam, you get the perfect answer in like a split second. It honestly feels like magic. Well, today, we're going to pull back the curtain and show you the brilliant and actually pretty simple idea that makes all of that possible.
All right, so here's our game plan. We're going to rewind the clock to 2005 to look at this huge search crisis. Then we'll use a pretty fun analogy to really get what was going wrong. And finally, we'll break down the powerful solution that, let's be honest, you've probably already used a dozen times today.
So let's set the scene. The year is 2005, and I want you to imagine you're a developer at this super successful e-commerce company. You know, things are booming, sales are through the roof, but that very success is creating a massive, site-breaking nightmare for you and your team.
And this is the one question that's just echoing everywhere. From angry customer emails to your boss leaning over your shoulder, why is our search bar so slow? What used to be this simple, helpful feature has turned into the biggest bottleneck on the entire site.
So, let's break it down. Back in the day, with maybe 5,000 products, a search was instant. We're talking 50 milliseconds, literally the blink of an eye. But now the site has millions of products, and that same search is taking a full 30 seconds to load. 30 seconds! In internet time, that is an absolute eternity. Customers are just gone.
And of course, the pressure is just piling on. It's not enough to just make it faster. Oh no, management comes to you with a list. They want it smarter, so the best results are always at the top. And they want it to handle typos. So if someone searches for, I don't know, laptop, they still find a laptop. It has to just work.
Okay, so the big question is, why was it so slow? To really wrap our heads around this, let's use an analogy. Think of your database as a library, run by a well-meaning but totally clueless librarian.
So the technical term for this problem is a full table scan, and it's really as bad as it sounds. It means that for every single search, the database has to look at every single row of data one by one. There are no shortcuts.
So, picture this. You walk up to our librarian and say, "Hi, I need all your books on machine learning." Now, a good librarian would know where to go, right? Not this one. This librarian starts at the very first book on the very first shelf. Harry Potter? Nope. Game of Thrones? Nope. Intro to Machine Learning? Ah, a match. But they don't stop. They have to keep going, checking every single other book in the entire library just to be sure they didn't miss any. It's exhausting.
And this process has two just fatal flaws. First, it is painfully slow. And the bigger the library gets, the slower it becomes. And second, there's zero concept of relevance. A book that's actually titled Intro to Machine Learning is treated with the same importance as some random novel that mentions the phrase one time on page 300. It's just dumb.
So, faced with this massive problem, the really smart engineers and computer scientists at the time realized something. Trying to make the librarian run faster wasn't the answer. They needed a completely new way of thinking.
They asked themselves a really simple but totally game-changing question. What if we just flip the entire problem on its head? And that was the breakthrough. The idea was this. Instead of waiting for someone to search for a word and then hunting through all the documents, do the work beforehand. What if you created a giant map, an index, that told you exactly where every single word lives before anyone even asks?
This incredible idea is the secret sauce behind modern search technologies like Elasticsearch. And it's all built on a data structure called the inverted index. Now, sure, it takes a bit of work and some storage space to build this index up front, but the payoff in speed, it's absolutely massive.
Honestly, the best way to think about it is like the index at the back of a textbook. You never read the whole book just to find a specific term, right? Of course not. You just flip to the back, look up the word, and it tells you exactly which pages to go to. Well, an inverted index is basically that, but for all of your data, on a massive scale.
So let's check back in with our librarian. They're not clueless anymore, they're a genius. Why? Because they have an index. Now when you ask for machine learning, they don't run around the library. They just look up machine in their index, boom, here's a list of books. Then they look up learning, boom, another list. All they have to do is see which books are on both lists. It's a quick lookup, not a full-blown marathon.
But here's the really cool part. Getting insane speed is just the start. This whole inverted index structure, it also magically solves those other problems we had, like making search smarter and handling typos.
See, because the index knows so much about where all the words are, it can start to rank things intelligently. It can look at stuff like term frequency.
Does this word show up once or 100 times in the document? Or it can do field boosting, which is a fancy way of saying, hey, this word is in the title, so this document is probably way more important. It's brilliant.
And it's the same structure that powers that awesome typo correction. The system can look at its massive index of words and make a really good guess that when you typed treading, you probably actually meant trending. So it gives you the results you wanted, not the ones you asked for. Super helpful.
All right, theory is great, but let's see the proof. We're going to do a real-world speed test, a head-to-head battle, the old, slow database way versus the new, modern search way. And we're going to test it on a dataset of 50,000 real product reviews.
So on the left, you've got your traditional database query. That I like command, that's basically sending our clueless librarian out to read every single one of those 50,000 reviews. On the right, we have the modern Elasticsearch query. This one gets to use our genius librarian with a super fast index.
And the result for the old way? To find one single word in 50,000 reviews, it took a whopping 7.5 seconds. Yikes. Okay, and now for Elasticsearch with its inverted index, doing the exact same search. The result? 500 milliseconds. Half a second. I mean, that's not just faster. That is a completely different world of speed. It's the difference between a user getting frustrated and leaving and a user finding what they want instantly.
So from now on, whenever you use a search bar and get that perfect, relevant, typo-corrected answer before you even finish typing, you'll know the secret. It's not magic. It's just the incredibly clever and powerful idea of the inverted index. And I'll leave you with this one thought. Now that you know the secret, just how many slow, clunky search bars are you going to start noticing everywhere you go?